Welcome to a Kong video tutorial about how to add observability to your application using Prometheus. I'm Andrew Q. Let's jump straight in. So effectively, what is observability? Observability gives you the insight into how well your application is doing. So with regards to the performance and the health of the application, and allows you for proactive management and resolution of problems. It also gives you the ability to monitor and troubleshoot your system. So whenever there's an issue, you can have the information you need to work out, how to resolve any of the issues. And it effectively gives you the ability to understand the behavior of your systems and hopefully detect issues early. So that's the proactive monitoring of your system and improve the performance and reliability of your platforms as well. Observability is actually built upon three pillars. The first pillar being logs. Logs effectively are the capture of events and activities within your system. They provide a chronological record of information like error messages and information and warning, and giving you that additional context about what's going on. It also helps your developers or your operation teams understanding the sequence of events and allowing them to get the context of what's happened and the visibility with the behavior of your system. Logs effectively can be consumed or stored in a number of different systems or platforms. Two really well-known ones used throughout the industry. One is Grafana Loki, and the other one is Elasticsearch. The next pillar is metrics. So metrics are effectively measurements of different aspects of your system's performance and behavior. They typically are data metrics of CPU, memory, consumption, request latency, error rates, and throughput. And they allow you to monitor the health and performance of your system over time, and then allows you to identify trends and anomalies within your systems. A de facto standard tool within the industry used today is Prometheus. There are other data stores that allow you to data, but Prometheus is one of the most well-known ones. The next pillar and the last pillar is tracing. So tracing gives you the visibility into the flow of the requests. When you've got these large distributed systems, you can see the flow through all of the systems and what's happening at every point through your distributed architecture. They capture the timing information and dependencies and interactions between all your components. And they allow you to analyze the performance and behavior of specific transactions or user requests through your platform. There are a number of tools that do tracing. Probably a few that you have heard of are Jaeger and Zipkin. Another Grafana tool which I quite like is Tempo. And the OTel collector, so OpenTelemetry collector, is one of the new tools that seems to be getting a lot of traction at the moment, giving you that abstraction away from a vendor, a particular tool, and sort of making things more generalized and allowing you then to push it on to whichever compatible backend that you have. So in today's talk, I will be talking about the second pillar, metrics. So collecting metrics using Prometheus. Let's talk a little bit about Prometheus so that we all understand a little bit about the tool before we jump in and do a bit of a live tutorial. So Prometheus has a number of key benefits that's worth us talking about. The first is around monitoring and collecting of metrics. So Prometheus is designed to store time series data and other various metrics from your servers or applications or services, so at a number of different layers. It regularly scrapes these targets and stores them in that time series database. It has a multi-dimensional data model, so it uses this flexible data model to basically allow you to identify different combinations of metrics. And it does this by using a key value pair of metadata called labels. This sort of enriched data model allows you to actually query and slice the metrics in a number of different ways across these multiple dimensions. It uses a pool architecture. So this means that Prometheus goes and actually pulls the metrics for you from your targets rather than relying on them to push the metrics to you. And this gives you a great benefit of more control and flexibility into what metrics it collects, as well as the frequency that these metrics are scraped. It has a powerful query model called PromQL. And this query language allows users to pull and analyze and collect the metrics out of the time series database. It also supports a wide range of operations and mathematical operations like aggregation and sort of time series based calculations as well. It has alerting and an alert manager built in, so you get that out of the box, and allows you to define alerting rules based on these metrics we've just spoken about and thresholds and patterns within the data that you're storing. It can trigger on these alerts and send out notifications when these conditions are met. And it allows you to handle sort of very flexible routing, deduplication, and grouping of these alerts, and allowing you to send them out to sort of other platforms and systems outside of Prometheus itself. It has a really nice service discovery and dynamic configuration feature. So Prometheus supports various service discovery mechanisms to effectively automatically find these new targets to scrape, as well as when they come offline, removing them. And it integrates into your most popular containerization orchestration platforms like Kubernetes to effectively discover all of the services and servers that you want to be scraping and monitoring. And lastly, it has a very rich integration ecosystem. So effectively has a very extensive community support. It has lots of client libraries to allow you to do easily instrumentation of your applications. And it offers a wide number of exporters as well, so allowing you to export data from a lot of other systems that you run. And we'll talk about a couple of those in the tutorial a little bit later. And lastly, but not least at all, Prometheus integrates into some visualizations tools like Grafana to be able to visualize and see the data effectively and in a really nice way. So that's effectively around Prometheus itself. Let's jump straight into a live tutorial. What I like doing is actually jumping into a tool like Lucidcharts, a whiteboarding tool, and let's actually draw out the architecture of what we're going to do. This gives us the ability of visualizing what the tutorial is going to do, and hopefully gives everyone an understanding exactly what we're doing today. So the first things first, we're going to be running everything on a Kubernetes cluster. And what we will be doing is effectively deploying Kong. We're going to be using Kong Connect. That is Kong's SaaS control plane. So we'll be making all of our configurations for Kong in Kong Connect. What we'll be doing in tandem is obviously deploying a Kong data plane, and this data plane will then be connecting up to the control plane, and the configurations will be syncing across to the data plane. So let's change those arrows around. What we'll then be doing is we'll be deploying Prometheus. So Prometheus itself, the time series database, will be deployed into the Kubernetes cluster. So I'll do that, and we'll be deploying the Prometheus operator Helm chart. So as part of that chart, we'll be getting a number of different services, which I'm going to talk through. First is the KubeState metrics service. This service will read and scrape all of the metrics at the Kubernetes cluster level and be sending those all down into Prometheus. The next we have will be one of the exporters, which is the Prometheus node exporter. The node exporter will get all of your node, so server level metrics. And in the case of Prometheus, it will get your metrics of the Kubernetes worker nodes that you are running. Next is your Prometheus Alert Manager. So the Alert Manager will be, we'll be configuring some alerts with particular thresholds. What's really nice about the operator Helm chart is that it comes with pre-configured alerts. So we can have a look at those and see what alerts are pre-configured in the chart. Lastly will be Grafana. So we will have a visualization tool to effectively have a look at all of these metrics that we'll be pulling in. Again, a very nice addition to the Prometheus operator chart is having these predefined dashboards that come out of the box. We'll have a look at those as soon as we jump into Grafana. And lastly, we'll be using Slack. So Slack, we will be configuring to send alerts from Prometheus Alert Manager to Slack. So just turn that arrow around. So the metrics will be going that direction. We will then be configuring Kong and Prometheus. So what will happen here is Prometheus will be scraping Kong on the 8100 endpoint, which is the status endpoint of Kong on the metrics path. And that's effectively how Kong metrics will be scraped. So this is effectively our architecture. That's what everything's going to look like and the services that we are going to deploy today. So I have a tutorial project that I will be following. I will share the link in the post. This is effectively what the repo looks like. I'll add the link in the description below so that you can follow along. This is the project that we'll be working on. So it is the Observability Prometheus project. And then I have a number of folders within here on every step, and you can follow and run the commands as we go through. So let's go into it and talk about each one in turn. And then you can follow it as you go along. So the first folder, cleanup, this is, as it says, it's effectively a cleanup script that you can run. And this will clean up everything that is being generated in the project. So you don't have to run it straight off the bat. It also deletes your connect configuration. So starting off, you don't have to run that. The first thing is the setup. Every script or every command within every folder has a number prefixed it. If it has a number prefixed, that's what you need to run. Anything without a number are sort of helper scripts that you don't need to run individually. So the first one is initialization. This will effectively install all of the dependencies that we need. I'm running a kind cluster, but to get the Docker process, I'm using Podman. The reason why I'm using that is it's an open source tool. Docker Desktop currently has changed its licensing, so I recommend using Podman. One of the first things I would do with Podman is actually increase the amount of memory it allocates for your cluster. It defaults to 2 gigs. I would put that up to 4 gigs. You then install kubectl, obviously, to communicate with your cluster. HTTPy I like using instead of curl. K6 to run some load testing. Helm to install Helm charts into your cluster. And K9 as a nice visualization tool. So let's go into that folder and let's run that initialization script. As you'll see, when my script runs, I already have all of this pre-installed. So it does check that before trying to install it again. I'm running this on Mac, so it's installing it using Brew, but please feel free to update it for yourselves to use something like Chocolatey if you are running this on a Windows-based system. Next, we will run the create cluster command. So this will effectively run and create a Kubernetes cluster using kind. As you can see, it's creating a Kubernetes node of version 1.29. And once that's finished, we will have our Kubernetes cluster come up. So give that a second to come up. Once we have done that, we can actually connect using K9. And I'm going to use this terminal at the bottom, run K9s, and you can now see that is my cluster coming up, and all of sort of your core components that are running on a base Kubernetes cluster. So that's everything running. That's all my pods running in the same namespace. You can see if I change namespace, I've got my default and all of your sort of base Kubernetes namespaces, and then a local path storage namespace as well. So that's my Kubernetes cluster setup. So let's move on to the next step. So 02 is installing Prometheus. So let's actually just have a look at what that looks like. So having a look here, you can see I'm effectively adding the Prometheus community Helm repository. And then I'm installing the Kube Prometheus stack Helm chart with some values and an override values file. So let's run it. I do cat out the values so we can see that. So let's run install Prometheus. So that effectively added the repository, updated my repositories, making sure I've got the latest versions of the Helm chart. And what you can see down here is my monitoring namespace has been created. So let me go into that, and we'll start seeing services being created in here. Give that a second while all of this starts coming up. So what I did do at the end of this was add cat out the values file that I'm running, and the only values that I'm really doing is setting this particular field within the Helm chart. This is just so that I can create service monitor resources in any namespace. Otherwise, it only looks in the namespace that Prometheus currently runs in. So this just allows me to create service monitors in any namespace. So that's the only thing that I have run. Otherwise, it's using your default values from that particular Helm chart. So while that's effectively starting to run and everything's coming up, let's look into the next step in the tutorial. So the next one, we're going to install Kong. So with Kong, there's a number of different parts of this that I need to do because, like I said, we are running Kong Connect. What we will be doing is effectively creating a number of different entities within Connect. What you need to do this is a Connect account. So if you navigate to cloud.konghq.com, you'll be able to register and create your own account. I've already got an account, so I'm effectively going to just log in with my current account. Once you've logged in, what we now need is a service account. So the first thing I'm going to do is navigate to organization. I'm then going to navigate to system accounts, and I'm going to create a new system account. So let's create the system account, and let's just call it Prom Tutorial, which is the tutorial we're currently using now. So save that. And now inside this particular service account, I'm going to add a team. So I need to give this service account permissions, so RBAC permissions, and I'm going to give it the control plane admin permission. So add that and save. Then I'm going to go to manage tokens because I need a token to be able to communicate with this. And I'm just going to call it tutorial. Let's call it Prom Tutorial. And I'll give it a 30-day expiration. So generate that, and then let's copy the access token. Make sure you copy this because once you've closed this window, you won't be able to get that token back again. Now, going back to my CLI, what I'm going to do is I'm effectively going to set a field called token and set my token in that particular field. The reason I'm going to do that is I'm then able to use that token in all my additional steps that I will be running. So now that I've done that, let's actually just look down here. As you can see, my Prometheus operator chart has finished installing. And just going through each of these, you can see the top one's Alert Manager. I've then got Grafana. I've actually got the operator itself, which manages the life cycle of Prometheus, Prometheus Stack, Prometheus itself, and the node exporter services. So all the services that I mentioned in our architecture diagram at the beginning. Okay, so let's move on to the installing of Kong, which I mentioned in the beginning. So the first thing we're going to do is we're going to create a control plane. So what I'm using here, there are a number of mechanisms for communicating with Connect, but I'm going to be using the REST API. And to do this, I need to give it the token. So all of my scripts that I'm going to be using with Connect will be giving a token. And effectively, I will be setting the region to EU, but I'm giving you the ability to override that if you want to. So let's do that and let's run this. So the first one I'm running is creating a control plane, and I am then passing in the token to that particular script. So let's run that, and then we'll go across to Connect and actually have a look at what's happened. So there we go. You can see I've got a response back from Connect. I'm now going to jump into my Connect, go to my gateway manager, and you can see I've now created a control plane called demo control plane. So let's jump into the demo control plane. And what you'll see is it's a completely blank control plane with nothing inside it. Next thing, what I'm going to do is I'm actually going to create some Helm values. And the reason for this, if you have a look at this response that came back from Connect, we're getting a number of important bits of information here. The one is the control plane endpoint. So this is a generated URL that is given to you for your specific control plane that you create, as well as the telemetry endpoint. So this is to send telemetry information up to Connect. These are the two bits of information that are very important for you. You need this to effectively configure and connect your data plane up to the control plane in Connect. So if I show you the values file that I've got, effectively what I'm doing is I'm going to be setting these values for the control plane endpoint and the telemetry endpoints in this value file for us to be able to install the data plane. So what I'm going to do, and again, as you can see, everything just takes the token and the region. So what I'm going to do is I'm going to run that particular script, and that is going to, there we go, generate my values file. And as you can see here, again, I just output it to the console. So that values file I showed, but now you can see my control plane and my telemetry endpoint values have been set based on that control plane that I just created a moment ago. Next, I'm going to create some certificates. So what is needed here is your control plane and data plane need some SSL certificates or TLS certificates. So what I'm going to do is generate those. So I've given you the script to do that. So let's generate those certificates, and again, giving it the token. So give it a token to it. That will run and generate those. And what it's actually done as well is upload those to Connect. And we'll go in and have a look at that in a second. But if you have a look here in the certs folder, I've now got my 2 certificates that have been generated. And this script effectively generated the certificates and then uploaded those certificates to Connect. So jumping into my Connect account, go to the overview of my data plane, and effectively looking at my data plane certificates, and you will now see that there is my certificate that I just generated and uploaded to Connect. So now with all of that in place, what we're going to do is the last thing, which is effectively install a Kong data plane. So All I'm doing here with this is effectively using kubectl now to create my Kong namespace. I am adding the certificates that we just generated into a secret, and then I'm installing Kong in that namespace with these the override file values that we just generated. So let's do that. So running that, and as you can see, there are no inputs into this because now we're just running a Helm chart. So running that, I'm just going to switch across so we can see. There we go. There's my Kong namespace created. If I jump into that, what you will now see is a pod starting, which is my data plane. If I just switch across to secrets and have a look, you can see there are my secrets, and jumping into that, you can then see there are my 2 certificates that are generated. Going back to my pod, and there we go. As quick as that, there's my data plane that has come up. I'm going to press L for logs, and we can see some logs coming through. Let's go back to our Connect account and go to my data plane nodes, and there we go, connected already. So we can see now there is my data plane node from my cluster. It's running version 3.6, and just give it a few seconds and the compatibility status should go into compatible mode. So there's my my data plane set up. Let's actually port forward this and have a look. So what's nice about K9 is I can use Shift F, which allows me to port forward. I'll port forward to port 8000. And if I come back to my console and run HTTP on port 8000, we can see now, there we go, I'm hitting connect. You can see that it's Kong. I'm getting the request ID and the latency, and obviously there's no routes. So that is effectively, a request coming through to my data plane. So now we've got Kong installed. Let's move to the next part of the tutorial, which effectively is exposing Kong metrics. So how are we going to do that? Well, effectively what we're going to do is we're going to create a Kong service. We're going to create then a Kong route, and we're going to add the Prometheus plugin to that particular route. So let's jump straight into that. What I will do so that we get some nice metrics coming out is I'm actually going to create an upstream and an upstream target, and then connect that to a Kong service. So that then gives us the ability of using the upstream mechanisms of Connect, which I won't go into a lot of detail in this tutorial, but we will see all of the stats coming through for that when we have a look at the metrics. So let's go to the exposing Kong metrics part. And again, we're using the token that we originally generated. So, and as you can see from the script, we just take the token and the region, or the region's defaulted to EU, so just the token into every script. So running that, we will then get responses back from Connect, and all of this just shows that effectively everything has been created. So let's jump straight into Connect and have a look at what we've created. So go into Network Services. You can now see I've got a demo service that I've been created. But the host that it's going to is just called HTTP bin, and that's because I've created an upstream. So let's go to our upstream. I've got it's called HTTP bin, and there is a target for that upstream, and that target is going to http://bin.org, which is a nice upstream that you can use where you can send requests to and basically just get a mirror of that particular request. So that's what I've just created. Next, we're going to create a particular route on that service. So let's do that. So if I run O2 and give it the token, we have now got a response. So going back to here, we can now go to routes, and you can now see there's our demo route with a path of demo. So that's effectively what we're going to call. So, but if I go into my service, you can now see that the route is associated with that service. So let's actually just call that service and let's have a look at it. So because I've port forwarded my data plane, I can just go HTTP. If I just do colon like that without localhost, HTTP pi allows you to not put localhost like that. You can just put your colon and you don't have to put localhost, which is a really nice feature of HTTP pi. And then I'm going to go to the demo path. And what you'll now see is that is effectively a response to HTTP bin. So you can see here the host name is effectively going there, and this is the request that got sent through. It's going to the anything endpoint, which is one of the endpoints that you use with HTTP bin. So that's all set up and working now. The last thing we're going to do is we're going to add a plugin. And what I'm going to do is I'm going to add the Prometheus plugin. The reason for this is effectively what we want is metrics coming out of this data plane, but in a format that Prometheus can scrape. And that's what the Prometheus plugin does. It effectively takes the status endpoint that Kong has that comes out of the box, and at the metrics endpoint, which is the default path that Prometheus scrapes on, the metrics will be transformed into a Prometheus style so that you can actually, Prometheus can scrape those metrics. So let's add it and then we'll have a look at that endpoint. So if I run the final script, and again, I give it the token endpoint, token variable, that will now add the Prometheus plugin. Let's go through and actually have a look. There we go. So now I've added at my service. You can add it at the service or the root. I've added the Prometheus plugin, and the Prometheus plugin, what I've done is I've enabled every single configuration because I want to pull all of the metrics. But this plugin gives you the ability to enable and disable any of these groupings of metrics. And this allows you to sort of tweak it based on your requirements and your use case. And it also allows you to reduce the impact because obviously generating all of this can have a minor impact, but this allows you to effectively adjust that as you want to. So now that we've got that added, let's actually go back to Kong and go back to K9. So again, Shift F allows me to port forward. I'm going to port forward on 8100, which is the status endpoint. And now what I'm going to do, just go to the browser because it's a little bit easier to see what's going on. I'm going to go to localhost 8100 and metrics. Going to that, you can now see that this is, if you're used to looking at what Prometheus metrics look like, these are all of the Prometheus metrics that will be scraped with this particular at this particular endpoint and using the Prometheus plugin. So we've now got Kong deployed, a service, a route, a path, an upstream, and the Prometheus plugin as well. So we are pretty much ready to go. Let's now start scraping the metrics into Prometheus. So how do we do that? Well, effectively, it's really easy to do. All we have to do, and I'm going to be updating the Kong installation that I've got, and I'm just going to be enabling the service monitor. A service monitor is a Kubernetes resource that comes part and packaged with the Prometheus operator, and it creates this resource which is configured in a particular way to tell Prometheus where the endpoints, the target is for it to scrape. This comes part and parcel of the Kong chart. So all you have to do is effectively just enable that service monitor. It will be created and Prometheus will start scraping from that endpoint. So just having a look at the script as well, there's no input parameters because I'm just doing an upgrade on that Helm chart, and I'm actually pulling the values from the previous step as well. So let's do that. I'm going to move into the next step, and I'm effectively just going to run enabling that. And what we'll see when that starts running, you can see how, again, I've output the values file. It's got all the values from the previous one, all of the endpoints for connect, and I'm just adding a service monitor configuration. So now in this namespace, if I search for service monitor, you will now see there's my service monitor. It's up for the particular data plane. And actually, if I have a look at the YAML of it, you'll actually see that it's looking at the status target port, which is the 8100. And the rest is pre-configured. You can actually configure a path if it's not the metrics path, but all of the rest of it is pretty stock standard. So now what I'm going to do, let's have a look at that. So let's change namespaces and go to the monitoring namespace. I'm now going to port forward on the Prometheus pod. So port forwarding Prometheus on 9090 is the default port that you want to port forward on. And let's go to localhost 9090. And this is the Prometheus UI that you get out of the box. I'm just going to go to status and targets. And what we will see now is effectively there is our data plane. So let's just open that up. You can see we're hitting the data plane pod on port 8100, and it's hitting the metrics path, which is that path that we just had a look at, this one over here. So Prometheus has already picked up that service monitor that we've just configured and is effectively now already scraping the metrics that are coming out of that endpoint. We can actually check that as well. So if I take one of these, let's just take this particular one, because not all of the metrics will be there unless we've actually gone and started pushing data through. But if I come to the home here, I can actually do some querying of the metrics. And if I start just typing in a particular metric, you can see here, these are metrics that are in Prometheus already. We can actually see that the metrics are there. And you can use this UI as a very quick way of seeing what metrics are there, sort of pulling the metrics out, executing it, and you'll start seeing some of the metrics already here. So a very nice way to just sort of debug and see what's going on. But even nicer than that, we'll be jumping into Grafana, gives you a much nicer visualization of what things look like. So let's move on to the next step. The next step is adding Grafana for visualization. So let's effectively do that. The first thing we're going to do, we've already got Grafana installed, but what we don't have is the Kong dashboard. So before we do that, let's jump in and port forward on Grafana. So Grafana works off of the 3000 port. So I'm port forwarding on port 3000. And then what I'm going to do is I'm going to come to port 3000 and you'll be given the login. So the login, the default user is admin. To get the password, all you have to do is come into the namespace where it's deployed, go to your secrets, and effectively come down to the Prometheus Grafana secret and have a look at that secret, and you will see the admin password is prom operator. A really handy part of this, which I haven't actually mentioned, is if you have a look up here, the shortcut is the X field does a decode of your secrets. So if I push the letter X, I get the secret decoded because they're just base 64 encoded. So that'll pull out, and that's effectively is my password. So I'm going to copy that, come back to Grafana, and I'm going to paste it and log into Grafana. So here we come into Grafana. What I want to show you quickly is actually the dashboards. So these are the dashboards that come out of the box with Grafana, which is pretty amazing in my opinion. Like, you're getting all of these out of the box. These are all managed and created by the Prometheus community. And if I just jump into one of these and have a look, so let's just have a look at the nodes. So you can see here, we're starting to get all of these really nice dashboards on all of your sort of data, and if you had multiple nodes, you would be able to pull out different nodes. So we go back to the dashboards. You can even see things on the Kubernetes level. So that's the kubelet, and this is the kubelet on your worker node of Kubernetes. So you can then see the node exporter information, actually even of my machine. So yeah, some really, really nice API server, some really nice data here that's pulled out, and you're able to visualize and look at it. So, but what we're going to do is we're going to add the Kong dashboard, and you can do that really nicely with the Prometheus operator Helm chart. And Kong has its own official Grafana dashboard. And if I go to that, if I go to Grafana Marketplace, and then you come here and you search for Kong, there's the Kong official dashboard, and there's the Kong Vitals Prometheus. So it is the official one, apologies. The 7424 is effectively the one that you want. So you can see here the dashboard that is exported via the Prometheus Kong plugin. So this is the one we're going to be pulling in. You can come here and have a look at the latest revision. So revision 11 is the latest one. So just make sure that when you deploy it, it is the 7424 ID and the latest revision. If it's increased in revisions, you can update that to the latest revision. I'm also going to be creating a Kong folder to put that in. So let's run that. And what that will do, you'll see that it's actually going to update some of the pods in this namespace. So let's move on to the next step. And we are going to run the add Kong dashboard. So that is effectively going to be doing an upgrade of my Prometheus operator chart. So give that a second, and you can see, there's a job that's just run, and there's Grafana rolling. So we are adding some new data to Grafana. So obviously the Grafana node, the Grafana pod needs to roll itself, and then effectively the other one gets terminated. Now, because we've terminated that pod, my port forwarding has been deleted. So let's go back here and let's port forward that port again. Go back to my browser and let's just refresh, log in with the same password. And now you can see I've got a Kong folder that's being created. And jumping into that, that is the Kong official dashboard. So this is what the official dashboard looks like. There's no data at the moment because this is pulling data from my data plane, which currently isn't doing anything. But what you do have, if I come down here, is you've got some stats at an Nginx level, because that's obviously not got anything to do with data going through, and some memory information, some Lua memory information. So you can see here already, this is the data that's been pulled through from the data plane, from that status endpoint through to Prometheus. What we're now going to do is we effectively are going to run a load test. So I've written a simple load test with K9. So here's my load test. It is effectively going to run for 2 minutes, and it's going to increase to 20 users. It's then going to run that for 5 minutes at a static rate. And then effectively it's going to then ramp down to 0 users for the next 10 minutes. So I've got a nice helper script which runs that for us. So let's start running that. We'll then jump into that dashboard and start seeing some metrics coming through. So if I run that, and you can now see this is the output of K9, and K9 is now running that script that I've just run. I haven't done it in this tutorial, but you can actually push these metrics to K9 and get, to Grafana in an Infomix DB database. And that then allows you to be able to get some dashboards for your tests as well. Another really nice thing that you can add to this. But for this particular tutorial, I haven't been doing that. So that's now starting to generate some metrics. We can actually see that if we come through to our status endpoint, and if I just start updating this, you can now see some additional new fields have been added. So this latency field, and as I start updating this, you can see that the values are changing. So we are getting values coming in. There we go. Now let's jump to Grafana and actually have a look at some of those metrics. So what I'm going to do is just change it to be the last 5 minutes. and I'm going to set this auto refresh to every 5 seconds. So that will auto refresh for me. You won't see data straight away. And the reason for that is actually if we have a look at this particular metric, so I can edit it here, everything is bucketed by 1 minute. So you'll only be getting data in for every 1 minute. So it does take a little bit of time, at least a minute for the data to start, getting into that metric. Let's just go back out of this, but discard. So after about a minute or so, you will start seeing data coming through. So let's give that a minute, and then everything will effectively be starting to generate. So you can see now we've now got some time frame there. So let's just wait for that to start coming through, and then effectively once we've got that coming through, we'll be able to start having a look at what that all effectively looks like. Give that a second. You can see things are starting to push through. Let's have a look at some of the other dashboards here. Open them all up and get ready for the data to start coming through. There we go. So that's starting to generate some metrics. And now we can start seeing some of our total requests coming through here. Let's scroll down a little bit and have a look at some of the other. There we go. So now we can start seeing some Kong latencies as well, which is really great to see. And this is what I was talking about before with effectively having the ability to see information around your upstreams as well. So you can see here, I'm also seeing latencies based on my upstream. If you didn't have an upstream and you just added a Kong service, you wouldn't see this data, which is why I wanted to add that. So looking then at my bandwidth, I'm now getting metrics coming through here. Having a look at my upstream information. Okay, this hasn't started coming through, but this will come through in a second as well. And we'll start seeing some upstream health as well. I'll just refresh my page just to make sure that that's coming through. And there we go. So what's really nice here is I've configured my upstream to actually look at the health of that particular upstream. So you can see here, there, I'm seeing that it actually is healthy. And this is one of the added features of the upstream mechanism. It's almost like a load balancer within Kong, which is a really nice feature. You can see that obviously HTTP bin.org has 4 different endpoints, 4 IP addresses, which is why I'm seeing 4 of those records there. And then again, you can see all of the data coming through within Nginx. Up at the top as well, if you had multiple services, multiple endpoints, you would be able to see all of them here. You can see there's my single service, and you can filter then based on that as well. There's my particular route, and then my upstream as well. So this gives you the ability to actually filter on all of your services and routes and actually see and dive into each one that you want to. But obviously then see everything at a very high level. What is the throughput coming through from my particular data plane? And, start understanding effectively what that all looks like. So that's effectively the dashboard. And that's us getting all of our metrics coming through and being able to dive into all of it and understand, what's happening with this particular data plane and the data that is effectively getting pushed through via our load test. The last step I'm going to have a look at is alerting. So effectively, like I said, there are a number of alerts that have been created out of the box, but you can obviously generate your own alerts as well. What I'm going to do is effectively just configure Slack, and we can do that via the Prometheus operator Helm chart. So what I'm going to do is effectively what I've done is I've set up a Slack channel, and I've already created one called Kong Prometheus tutorial, but you can effectively come to your Slack organization and create a channel. So just create it, whatever you want to call it. Then what we want to do is we want to now generate a webhook. So what you do is you come here and you go to the tools of that particular workspace. So let's go into that workspace. You then come to configure apps. You go to build. You can then come here and create a new app. So let's just create one from scratch. I'm just going to call it Prometheus tutorial. Select a workspace. So I'm going to do my workspace, which is called Quad Demo, and I'm going to create the app. Now that I've created the app, I'm then going to come to incoming webhooks. I'm going to click that, and I'm going to turn incoming webhooks on. With that on, I'm then going to come and I'm going to create a webhook. Create your webhook. Choose the channel that you want to push it through to. So mine's called Kong Prometheus tutorial. Click allow. And I've now connected up with this webhook. You can come here and click copy. So let's click copy. And then let's move through to here. As you can see, the field or the input into this particular script is the Slack webhook. So let's come back here. I'm actually just going to stop my performance test, and let's move on to the next step. So in the step, I'm now going to run configure Slack, and I'm going to pass it my webhook and run that. And effectively what this is doing, again, is upgrading my Prometheus chart, the Prometheus operator chart, and it's now configuring Prometheus Alert Manager with the Slack configuration. So if I just go here, it's probably easier to see it with what gets generated, but effectively in Alert Manager, I'm able to configure my Slack endpoint, and effectively you can see here it's configured the channel, and then it also sets the title and the text. So this is all configurable, and you can set that effectively however you want. So gave that a little bit of time, and actually let's jump straight into Slack and have a look what's happened. So you can see here that I've added an integration called Prometheus. Oh, there we go, a Prometheus tutorial. And straight off the bat, I've already got some alerts coming straight in. So really nice. Like I was saying, these alerts are out of the box with Prometheus Operator. And what this gives you is the ability to see these alerts when they are firing. Out of the box with Prometheus Operator, you get a whole lot of alerts that are a really good starting point, in my opinion. And pushing them to something like Slack or Teams, which is another option, it gives you the visibility to actually see, what's going on. And you can see here that I'm already getting 2 that are firing. You'll be surprised at sort of out of the box what gets fired from your alerts, from these ones out of the box. You'll have particular requirements based for your organization as well. So, create your own alerts, do that and push them through. And when you have this mechanism all set up, then obviously you'll start seeing those alerts all firing through and getting that visualization. You can push it into other tools as well. If you're using the likes of PagerDuty or ServiceNow, Prometheus has the ability for you to send those out to those endpoints so that your support teams can actually start seeing those alerts when there are issues coming through. So yeah, that's the end of the tutorial. That effectively, if we go back to the Lucid chart, we have effectively gone and built exactly this. We have deployed Kong with Connect, connected it up, and got some configuration with a service, route, and a plugin. We've deployed Prometheus, Kube State metrics to get the Kubernetes metrics, the Prometheus node exporter, the Prometheus Alert Manager, and connected that up to Slack, and Grafana for visualization. So that's the end of the tutorial. I hope you enjoyed it. Again, you'll be able to get all the links in the description below. I hope you all have a nice day.